Hey everyone, welcome to episode 2 of Find the Air. This time it's a physics problem solving the net force. So we're going to do some vectors, and here we go. Three forces are applied to a ball in the middle of a room. The first is 20 newtons at 80 degrees from the x-axis. The second is 30 newtons at 140 degrees from the x-axis. And our third force is 15 newtons at 200 degrees from the x-axis. I've been asked to solve the net force of the ball, so I'm going to break that into components. The x force uses coses, so we set this up as 20 cos 80 plus 30 cos 140 plus 15 cos 200 degrees. Everything looks good. We fill that into the calculator and we get a net force x equal to negative 33.6 newtons. It's negative, that means it's going to the left. Our net force y is going to use sine values instead of cos values. Sine values are up and down. 20 sine 80 plus 30 sine 140 plus 15 sine 200. And this is going to give us our net up and down force. We plug this into the calculator and we get that our force y is going to equal 33.8 newtons. So it's going to be going up when we draw that vector. Everything looks good so far. We're going to shove this up as long as there's no mistakes yet. I'm going to go ahead and draw a triangle to show these vectors. Draw a little circle for our starting point. Our x component is to the left, so we draw the vector to the left, and we go 33.6, and then we're going to go up, and we're going to go up 33.8. We can connect these vectors with a little hypotenuse, and this diagonal, that's our force net. Oh, we got this. Easy stuff. In order to get that, we're going to have to do a little bit of Pythagorean theorem. Shouldn't make any mistakes here. C squared is equal to a squared plus b squared. We can go ahead and fill in our known values by saying that c squared is equal to 33.8 squared plus 33.6 squared. And I can go ahead and put those in the calculator as well, and it's going to give us a value of c squared is equal to 2,271.4. Take the square root of that, gives us c, 47.7 newtons, and bam, we have a force net. No problem. But you're not catching me that easy. I know that vectors need an angle component, so we need that theta. I thought you had me. Not yet, you don't. In order to get this theta, we're going to use tan, because we have the opposite and the adjacent. Tan of theta is equal to the opposite, 33.8, divided by our adjacent, 33.6. We can plug that into the calculator and we're going to get that theta equals 45.2 degrees, and now we have a magnitude and we have an angle, so our final answer is force net is 47.7 newtons at 45.2 degrees from the x-axis. Just like that, we have our vector. Unless I did it wrong. Were you clever enough to spot my mistake? If so, give yourself a little smile and a little cheer, and feel free to leave a smile in the comments below. Just don't spoil it for everyone else. Thank you very much for playing our Find the Air, and I hope you have fun, and I'll look forward to seeing you next time.